All right, so we're going to be looking for the minimum weighted tree, and I've got two methods. Okay, so first is Kruskal's algorithm. So we're going to find the weighted graph, and we want it to be a tree, a minimum spanning tree. So we want the weights to be the smallest. So what we're going to do with Kruskal's is we're going to add one by one in order of increasing weights. We look for the least amount of weight. So in here it's like number of miles, right? So I'm just going to make a list over here. So 83 is the smallest, correct? So I'm going to pick up that edge that's weighted 83, and I'll just put it here, and I'll just say L to C. So remember, I'm making a tree with the minimum weight. And that's what Kruskal's algorithm does. So now I'm looking for the next smallest weight. Oops, I missed one, didn't I? 74. 74 is the smaller weight. So I should have done that one first, right? So here's C to M. Okay, so that's 74. So that's the smallest weight. Then there's the second smallest weight. So now I'm looking for the next smallest weight, and that looks like 151. So I want to include Louisville to Nashville, right? So that's the 151. Okay, so I'm looking for the next smallest weight to make this tree. Remember, it's a tree, so I cannot make a circuit. So the oops, that 151 I meant to write. Okay, so next would be 230. That would be the next smallest weight. So there it is to Detroit. So there's 230. D for Detroit, 230. Okay, just keeping track of which ones I have, right? So then I'm looking for the next smallest weight, which I believe would be 242, right? So that's taking Louisville to St. Louis. So St. Louis, that's 242, 242. All right, so the next smallest weight would be, well, if I did 269, think about it. If I included this one here, that would take Louisville to, is that what I want to do? Oh, no, never mind. 262 is smaller than 269, right? So 262. So that gets me St. Louis to Chicago. So there's 262. To 262. That's my next smallest. Okay. So now my next smallest would be 269. But if I included that edge, that would take me from here to here, and that would not be a tree anymore. So I'm not going to use 269. So then I'm going to go to, what am I missing still? I'm still missing Minneapolis, right? And, oops, I forgot to include an edge. There's supposed to be an edge. Oh, shucks. There was supposed to be an edge from Chicago here, and this was supposed to be labeled 355. And so that's what I'm going to include. So this goes to here, to Minneapolis, and this is 355. So now do I have all the vertices? Milwaukee, Minneapolis, Chicago, yes. Detroit, Cincinnati, Louisville, St. Louis, and Nashville, yes. So all of the vertices, and it's a tree, it's connected, and this is the smallest weight. Okay, that's using Kruskal's method. Okay, so Kruskal's method is you just add one at a time, and you saw that it wasn't connected at one point, right? Prim's method builds a spanning tree, and it'll always tell you where to start, and so we always want to keep it connected. So we don't always have to continue on from the same place, but we have to keep it connected. So if we're starting at Minneapolis, so here we are, starting here with Minneapolis. So I want to pick the smallest weight. So the smallest weighted edge would be the 355, right? So I'm going to include that one. So that gets me to Chicago. Okay, so then I can move out from this vertex, or I can move out from this vertex, but I'm looking for the next smallest weight. So of course it's going to be this one with 74 to Milwaukee. So I move out from this vertex, or this vertex with the next smallest weight. So the next smallest weight is going to be Chicago to St. Louis. So St. Louis. Okay, so then again, I move out from this vertex, or this vertex for the next smallest weight. So it's going to be this one from St. Louis to Louisville. And again, any one of the vertices I move out from to get the next weight, lowest weight. So I'm going to move out from Louisville to Cincinnati, because that's 83, right? There's, I should have put this one down as 242, and I should have put this down as 262. Okay, so now I'm looking for the next smallest weight from any one of the vertices, and I'm pretty sure it's this one right here to get to Nashville. That's 151. And then last one would be here to Detroit, 230. And look at that, it turns out to be the same in this case. It's not always, but there's two different ways to go about it.